Good day, sir. My name is Sizwe Mkize, a BTech student in Process Instrumentation and Control System. Today I'm going to present the project of an Arduino-based color sorting machine. In this video, I'm going to talk about the housing of this color sorting machine, the electrical components, and the operation of this machine using this item as my pointer. This project is an Arduino-based color sorting machine. It will use both software and hardware components to accomplish the sorting task. The basic operating principle of this machine is based on the color theory of absorption and reflection of lights, which are red, green, and blue, also using an array of 8x8 photodiodes that changes sensitivity or wavelength when subjected to different colors. The color of the skittles will be sensed and placed at different containers according to their color. Skittles are fruit-flavored candy produced and marketed by specific food processing company. This project will distinguish color mixture of red, blue, green, and yellow, which will be used to improve quality control in industrial process. This project is a closed-loop system. The measured variable is the color of the skittles. Our primary element is the TCS 3100 color sensor, which produces a light frequency based on the measured variable. Our set point is the wavelength from the calibration of RGB values. The error is the difference between the set point and the light frequency from the color sensor. Our controller is an Arduino Uno, which produces a pulse width modulation signal to actuate the SG90 servo motor. SG90 servo motor is our actuator to produce a rotation or an angular motion. The process is the color sorting mechanism. The next section I'm going to talk about is the housing. The housing is made up of a strong non-conducting material which is insulated by a black insulation tape. Our housing also have 4 cable ties of different colors. We have a red cable ties, we have a green cable ties, we have a yellow cable ties, and blue. These cable ties were chosen because they correspond to our measured variable. Starting at the top, we have a hollow tube. The hollow tube will receive a skittle at the top, drop it down to this semicircle skittle displacer. This semicircle skittle displacer will rotate from 0 degrees to 115 degrees in front or underneath the color sensor. After the color sensor has sensed the color, then the semicircle skittle displacer will rotate 65 degrees to drop the skittle to this guardrail. So this guardrail will rotate to a certain angle depending on the color that is sensed to drop each skittle inside these containers. We have 4 containers at the bottom. We have a red container that will receive red skittles. We have a yellow glass container which will receive a yellow skittles. We have a green container which will receive green skittles. And lastly, we have a blue glass container which will receive blue skittles. And also these are our skittles or our measured variable that will be sensed. The next section that I'm going to talk about is the electric components, starting at the power supply. All Arduino boards need electric power to function. A power supply is what is used to provide electric power to the board and typically can be a battery, a USB cable, an AC adapter, or a regulated power source device. Modern Arduino boards allow the board to have more than one source of power to be connected simultaneously. An intelligent switching circuitry ensures that the highest available voltage is selected and sent to the onboard voltage regulator and eventually powers up the board. By looking at this power supply, we can see that its input is 220 to 240 VAC 50 Hz and the power is 18 watts. So the range of outputs is 1.5 volt DC up to 12 volt DC. You can see that you can select which voltage you choose on your application. I chose 7.5 volts because it works better with my Arduino Uno. Also, we have an on and off power that switches on our power supply and off whenever you don't need to use this power supply. On my right hand side, we have a 9-volt battery. As you can see, this 9-volt battery will use to power the Arduino Uno using a DC jack center positive. We also have a 1.5 times 4 volt batteries connected in series to produce a maximum of 5.6 volts. So this multimeter will be used to measure the power that is used. Going back at the bottom, so these volt batteries that are connected in series will be used to power our top and bottom servo motor. And then on my left hand side, we have a standby power supply. So in case these batteries runs flat, we have a standby power that will supply the power to the motors. And the last section I'm going to talk about are our 4 major components, which are SG90 servo motors. I'm going to start with SG servo motors. We have a bottom servo motor and then we have a top servo motor. These are SG90 servo motors. The function of the top servo motors is to rotate the semicircle skittle displacer from 0 degrees to 115 degrees in front of the sensor, and finally to 65 degrees to drop the skittle. That's the function of the top servo motor. The bottom servo motor, its function is to rotate the rail guard from 0 degrees, it could be 85 degrees depending on the color that is sensed, to drop the skittle to one of the containers. And then we have a color sensor which has 4 white LEDs that shines or illuminate the subject of the skittle. As you can see where it's shining, we can't see clearly the TCS3200 color sensor because it is covered with a black box that is insulated with a black insulation tape. We're doing so to compensate for ambient light, because during the calibration the ambient lights affect the values of the calibration. We use the black color because we know that it absorbs most of the lights. And then we have our main controller, which is an Arduino Uno. As we can see, it is facing downwards to support the color sensor. So Arduino Uno can be powered also using a USB cable. A USB cable can be used to power our Arduino stable and also can be used to transmit data, in this case an Arduino code, from the laptop or any PC. Okay, the code will drive the entire system. So lastly, we have an I2C LCD display. Whatever color that is sensed, it will be displayed here. I chose I2C LCD display because it doesn't use many wires, only just 4 wires, which are VCC, ground, serial data line, and clock line. So the wires are at the back, obviously you can see. And in the next video, which will take less than 1 minute, I'm going to show the operation of this process. Thanks for watching.